Okay. Well, good morning, everyone. Welcome to and thank you for joining. Welcome to our Forward Thinking Farming webinar series powered by the Pioneer Agronomy Network in Canada here and in North America. We're happy to join you today. My name is Chris Olbach, and I'm a product agronomist in the province of Ontario. And this morning, we're going to cover and explore a new foliar leaf disease to Canada, relatively new. But it's regularly impacting the crop here in Ontario and Quebec now, and it's called tar spot of corn. So now, like foliar leaf diseases are nothing new in the province of Ontario and in the Great Lakes. We've dealt with them for a while, but what makes tar spot different and maybe a bit of a unique challenge to the Ontario producer and to the Canadian producer is something we want to cover today with you. So moreover, we're going to look at the pathology of tar spot, so that you can perhaps understand it a little better for your operation. What we've done in the past, present, and future with respect to tar spot, and maybe how we can better work on your position with your business and how you can manage your corn crop better with respect to this disease. So to do this, we have a couple people joining us today for the conversation. First, we have Peter Horevaj joining. Peter is our Corteva North American field pathology lead. So he's joining from New Holland, Pennsylvania, just south of the border here. So we're happy to have him. He's got 12 years of experience with our company, looking at pathology in corn from all things. We've heard from him on gibberella ear rot, northern corn leaf blight, and has been a great resource for us to work with. So today he's going to give you a bit of an idea of what tar spot is and how to manage it in your corn crop. And from there, we've also brought in Mary Gumz. So she's an agronomy innovations manager in Eastern United States. She's joined us as well, and she's going to cover off some of the experience in the U.S. Up till about 10 years of tackling tar spot in the United States so far. So a great resource to have with us today. From there, we have some local agronomists that I'll try and jump in as we go into the latter half of the presentation. We have John Seliga today, and he covers Lambton Middlesex area as a field agronomist and sales agronomist with Pioneer. And then we have Greg Stops as well joining, and he covers Huron Perth. So we have a wide range of experience with you today, with you here today. So we're excited to be unpacking tar spot a little bit with respect to your operation, and hopefully cover some of the things with this seemingly innocent but fast-moving pathogen in corn. So without further ado, I'm gonna hand it off to Peter Horevaj to give a bit of an introduction to himself, but then also kind of talk about tar spot, what it is, what makes it different from other diseases, and how you can start to understand it a little bit better. So Peter, take it away.
Thank you very much, Chris, for introduction. And so let me share my screen. So can somebody confirm that you see my PowerPoint and you hear me good?
Good.
Okay, thank you, Chris. So yeah, I did like how Chris said that we are gonna unpack a little bit. So yeah, let's unpack a little bit on tar spot, and my portion of the talk is really gonna concentrate on the pathogen and kind of on the pathosystem. So it's gonna be kind of from the pathology point of view, to give some overview of the disease. So we'll just jump straight to it. This is kind of maybe the typical look that you can see on the leaf, that tar spot, what it can do in the corn, at least in the earlier stages. So what is it caused by? The tar spot is caused by microscopic fungus, so it's a fungal disease. And up there you have the Latin name in science, so we can communicate better across the world and countries. We have these Latin names. It's not just make too complicated, but also to better improve the communication with the researchers. So it's called Phyllachora maydis. Maydis from maize, from corn. And what it does, or what it creates in the leaves, what you can see are those black lesions. They are called stroma. They are usually, if we compare with other disease, foliar diseases, they are relatively small. They actually, you can see even on this picture, they are kind of raised a little bit above the leaf. And in terms of shape, generally they are round, but they can elongate a little bit in some cases. So we say that they might have kind of irregular or kind of spindly shape as they start elongating. What is interesting, I would say, for this disease or this pathogen, that those black stroma that you see on the leaf, that's actual pathogen. So, comparing it with other diseases like northern cone leaf blight, let's say, or I would say even probably it's not a problem of the yeast, or Goss's wilt or GLS. What you see, those lesions, that's just a necrotic tissue of corn, but pathogen is somewhere inside. But in this case, you actually see the actual tissue of the pathogen, those black stroma. So what is hiding underneath those stromata? There was a nice study done that was actually published just this year, in the middle of the year, I believe in May of 2024. They did nice work, the researchers. They did cross sections and there is a bunch of pictures in their study that they publish, electron microscopy and so forth. But I picked this one picture just to illustrate what is underneath in that black stroma. So basically the pathogen is there, and I would say in terms of the spores, there are two fruiting types of bodies. It can be either this perithecia, what is the sexual stage of the fungus, and there you can find the ascospores that are here on the left, or you can have pycnidia, that's another type of, sac, I would say, like containing the spores, and those are the asexual spores. So you can think about it as generative and vegetative stage of the fungus. Generally, so far, what is understood, mainly the ascospores actually cause the reinfections in the other stages throughout the season. So that's in terms of what is hiding, in those black stroma. So it's body of the fungus and mainly spores that are getting ready to be released. I wanted to talk a little bit or show at least this one slide about the history of this disease, star spot. So it's actually not a new disease in terms of world view. It's actually more than a century old. It was first identified in Mexico in 1904, so that's more than 120 years ago. And then in general, this disease spread throughout the Caribbean and was reported in South America in following decades. So it was considered as a disease of tropics more. One difference there is that there is known more as a disease complex. What that means is that we have actually two pathogens causing disease in tropics. It's, that stroma called those black spots by Phyllachora maydis, but also there is another pathogen, Monographella maydis, that is causing those fisheye lesions, the necrotic tissue, and that's in tropics actually causing more problems in terms of, the yield reduction. We don't see that here in North America. In North America, I should say US and Canada, we see only Phyllachora maydis, not the other pathogen. So that's one of the differences. So, what happened suddenly in 2015, they started being reports and observations of tar spot in corn. So And then in following years, it started spreading from first reports were in Indiana, Illinois, in this area. And then it started spreading the following years across the US. And, this is current spread. I have heard that, it was even reported in Quebec. So there should be soon, there is going to be some county lit up eventually. So in terms of, people wonder what happened, there are several hypotheses. I'm not going to say exact cause because I don't think anybody exactly knows. There was it brought by inadvertently or accidentally on the plant tissue. Another one would be, did it ride the hurricane up there, or predominant storms? That was another explanation. Other possible causes, or what I have heard or what was discussed in scientific community, is the genetics, germplasm across the industry changing, and suddenly that is it more susceptible? That was another possible cause or hypothesis. Or did something change actually within the pathogen that was suddenly able to show up in the central US, I would say, and then spread throughout. So those were kind of a possible hypothesis. I want to discuss one study that was published actually 2 years ago, and a little bit expand on this. You don't have to worry too much about all those graphics there. What I want to just to describe is these authors, Brothers and others, it was long list. You can see it there at the bottom of the slide. They did a nice study in 2022, so it would be 2 years ago. They actually screened more than, I think, 180, almost close to 200 different isolates. Isolates, you cannot think about them as a samples of this Phyllachora genus. So not just Phyllachora maydis, but Phyllachora genus. They got samples from across the world and across other species, not just what was collected from maize, but also from the other hosts, primarily grasses. This Phyllachora genus, it's known to cause star spot on the other plants like grasses. So it's not just causing problems or disease on corn. And then what they did, they basically assessed the sequences of all those samples, and they were running analysis trying to genetically group them into the different groups. And what was interesting, they came up with 5 different kind of distinct groups, what they called Phyllachora species. 3 of those, so that would be a kind of color-coded to match their graphics. So that would be species 1, orange, then green, 2, and purple. It's what's having the biggest, oops, I skipped the slide, okay. The biggest geographic distribution. And what was interesting, some of them were just from corn. That's what we would expect. If it's Phyllachora maydis, it's going to be just on corn. And, it was grouping by itself. Either from US or from the US and world. But this Phyllachora species 3, this group that they were grouping still genetically closely, they were found across 10 other hosts, not only corn, but also a lot of grasses predominantly. And some of those samples, what was interesting for these studies, they got samples from herbariums. So they actually had even like the original sample from Mexico that like 100 years old, those samples, I guess some dried leaves. They were able to isolate DNA. So what was interesting that some of these samples that were closely grouping with corn, Phyllachora maydis, were from grasses that were from like 60 years ago, also collected from some grasses in southern US. So that was one of the like these authors were proposing or kind of throwing the thought out there that it might have just, we would call it, jump the host, that it might have been for some time in other hosts, and now it was also something might have genetically changed. So that was one of the hypotheses that is out there that could explain like how it suddenly started showing up also in the United States. In terms of disease cycle, we know it overwinters on corn, on the residue, in the US conditions, or Ontario has been for a couple of years by now. It likes moderate temperature, 16 to 23 Celsius. So it can deal with cool weather. It doesn't need warm weather or hot weather that we would think or expect from disease from tropics, because actually in tropics it's much in higher altitudes. It needs leaf wetness, more than 7 hours, and high relative humidity. And what I want to also highlight here in this disease cycle is that it's latent period. Latent period means time from infection until you see the symptoms. So this period, that time is pretty wide or long comparing with some other foliar diseases. So it can pass 2 to 3 weeks until you see the symptoms. So you might have had, if you start seeing those tar spots on your leaf, you might have had infections 3 weeks ago. And because it is polycyclic disease, polycyclic means that it can cycle, it can have several generations throughout the season. So if you are seeing those first star spot stroma, you might have had maybe second or third wave already infecting, but you just don't see yet the stroma. So that's what can cause kind of like that overwhelming effect that suddenly people say that it just changed so dramatically. Well, it might have been cycling in last 3 weeks, and you just don't see the result of it yet. So it can have a pronounced impact on yield. Seems like it's very weather dependent. This is the picture from one study done by the researchers. I think it was a fungicide study where they had non-treated control of, obviously they chose some susceptible hybrid for that work. But you can see there, according to their pictures, this was just over the 2 weeks period, that how things could, dramatically change in very susceptible genotypes or hybrids. So the yields were being reported even up to 50% in some extreme cases. In terms of what you can see there, you can see, just depending on the genetics of your hybrids, you can see just some really individual spores, stroma, those black spots, or you can see what we see very often when you are starting having more like dense stroma, that it starts just overwhelming those leaves and they just start turning necrotics first in some spots, and then you can get majority of the leaf. Usually it's towards the tip of or starts from the tip, seems like that necrosis, it's just overwhelming everything. But we do see also in United States these fisheye lesions. So that's something interesting that, like I was saying so far, the scientists were not able to isolate from those necrotic fisheye lesions these other pathogen. So that's something what we still are learning or trying to answer. Why are we seeing in some cases these fisheye lesions, but no really parasite or pathogen within them? And you can get it even, I got this picture from one of the fields this year, you can get it on the husk leaves as well. So it's not just on the leaves. So I would end, this is my last slide for my portion. I would just end with kind of an outlook or challenges, what we as a pathologists, society, I would say, not just Corteva, but even across the industry and even the academia, what we deal with, it's an obligate parasite. What does that mean? It's kind of like those rusts. You cannot culture it on the artificial media. It just needs to be, it can just grow and, spread on the host, on the corn in this case. So that does complicate the research because you cannot have inoculations done the traditional way, just make, inoculum in the laboratory. So you can just, you can spread just on the corn. We are still trying to learn or understand better the pathosystem, like I have in this picture, that why, like I said, about why we are seeing in some cases these fisheye lesions, but we don't see other pathogens there. There is still work needs to be done in terms of understanding the genetics, the population. Does it have another host that we don't know about, or is it just really corn, or how come it spreads like here to the US? So there are still some questions that need to be answered, and obviously the host resistance that as a seed company we also need to better understand and working towards developing more resistant hybrids for the future. So I would end here, and we can transfer to Mary to discuss more in detail the US experience with this disease here.
Just as Mary's taking control, I forgot to mention at the start, if you have any questions, there's a chat function on Teams that you can use to ask some questions, and we'll address those towards the end as we have time and as we get into John and Greg's portion as well. But yeah.
All right, thank you, everybody. Chris, can you hear me and see my presentation right now?
Yep.
All right, great. Good morning, everybody. I'm glad to have been invited to be here with you this morning. My name is Mary Gumz, and I'm the Agronomy Innovation Leader for the U.S. Eastern Corn Belt. So I cover the states of Minnesota, Wisconsin, Illinois, Indiana, and kind of everything north and east of there out to the Atlantic Ocean. So I border a good part of Ontario, as well as Quebec and your Eastern Corn Belt as well. And so we've had tar spot in the United States for about 10 years now. And there's some things that we've learned that we'd like to share with you. Number one thing we've learned is once you have tar spot, you have tar spot. If it's not in your field, it will be coming to your field. Gradually, you build up enough inoculum that it becomes one of those perennial threats, just like northern leaf blight or gray leaf spot or any of those other common corn diseases that we have. I have some maps showing the progression of the disease since 2015. And actually, if you look at this little county in Indiana, that was one of the first places that was discovered in 2015. This was back when I was a product agronomist for the company, and I had one of our impact plots, the plots that we use to evaluate our germplasm before it becomes commercialized. I had one of those plots near Logansport, Indiana, and there was a day I noticed that there's something weird going on out there. These plants looked like you had just taken a paintbrush and dipped it into a bucket of road tar and flicked it on the plant. Just these little raised black blotches, and definitely very odd. And about a week later, Purdue University had in their newsletter this new disease that we were suddenly seeing in Illinois and Indiana, called tar spot. And there was some speculation that had come up on a hurricane. We had Hurricane Bill early that summer. And so that was the speculation that maybe this might just be a fluke thing that we were seeing. And so in 2016, we saw some random occurrences of it again. And actually, the county that we initially saw it in, we didn't see it in that county again. It was just kind of randomly in other spots. So we figured, okay, this is going to be something interesting, but not a big deal. And then all of a sudden, 2017 happens. Then 2018 was the year that it really blew up. And I'm going to talk about this 2018 outbreak that we had. 2019, a little bit lower level, but kind of stayed to its geography. 2020, it keeps moving out mostly to the east. West, it seems like when we get into Iowa and Nebraska, things get arid enough that the disease doesn't spread as much. But 2020 is when we first start seeing it in Southwest Ontario as well. 2021, it continues to spread, and this is another notable outbreak. 2022, and then this is the final map that is on IPM pipe for 2024. And so you can see it's spread pretty extensively in Ontario. And I know from talking to Chris and Greg that it's all the way over in Quebec as well, but it's not showing up yet on this map. So you can see that we're really expanding this the footprint of tar spot. It loves humidity. The Great Lakes are just kind of a natural incubator for it. And so we're seeing it spread along the Great Lakes, along the eastern seaboard. Any place where you've got that humidity to sustain it is really where you're going to see it quite a bit. So those two notable outbreaks, like I said, were 2018 and 2021. In 2018, this was the year that it really moved into northern Illinois and into southern Wisconsin. And we saw those cool, wet conditions again early, and the disease just took hold. And there was another thing that was going on, that we had some weather conditions that led to a lot of crown rot and kind of early season root rots, other stresses. It turned dry for a while later that summer after the plants had been sitting in fairly wet soil for a while. And we found that when tar spot came into one of those fields that was already stressed with something else, it just took over. It accelerated any other stress that the field was seeing. 2021 was a little bit different. We were wet early, but then it was actually a little bit of a drier year. And what we found was that that wet early was enough to get things infected. And like Peter said, we had this very long latency period. And so it came back later in the season. You can see some pictures here from northern Indiana. August 28th, the plants in this field were just fine. By September 23rd, less than a month later, they had just completely melted down. And so we found out that latency is real. And even though things looked good earlier in the summer, it was kind of there waiting for us. This was an interesting year too. We found in some areas where we had irrigation that the irrigated part of the field actually had tar spot far worse than the dry corners. So that made us realize that irrigated fields in tar spot areas, we're going to need to do some management so that we have maybe fewer irrigation events of a greater volume rather than putting on a smaller volume more frequently. So one of the silver linings that came out of the storm is that we found out that there are actually big differences in hybrid susceptibility to tar spot. And the number one way to manage this disease is through hybrid selection. You can see here we've got different leaves from different products that were in one of our big impact plots. And so you can see there's definitely a differential in how hybrids respond to the disease. And this is really encouraging because if you have a different tar spot response by hybrid, that means we've got different genes that confer tar spot tolerance or tar spot susceptibility, just like Peter was talking about. And we have identified some of those specific areas on chromosomes that are responsible for those differences. And the next step is really finding those specific genes or those specific areas of genes that we can make sure we put into hybrids and change that tolerance and more into resistance. So can't have a disease talk without having the disease triangle in there, that in order for a disease to occur in a field, you have to have three things. You need the pathogen, you need the tar spot in there, you need the right environment, you need that kind of damper, cooler environment like Peter talked about, and you need a susceptible host for it to grow on. If we can plant a tolerant hybrid rather than a susceptible hybrid, you really decrease that host part of the disease triangle and really decrease the likelihood of a catastrophe out in the field. We've been able to rate most of our hybrids in Pioneer, at least our early to mid maturity hybrids, because we've had 5+ years of fairly heavy natural disease pressure. And you can see from the dots on this map, we have a lot of research plots and impact plots throughout this area. So we've been fortunate that we've been able to take ratings of our hybrids for the last several years and have really seen that differentiation between hybrids. And in fact, this is from one of our protocols for scouting. You can see the difference on the same day. We've got hybrids that have a trace. We've got light tar spot, moderate tar spot lesions, and then you can see the heavy lesions where you not only have the tar spot lesions, but it's also killed the leaf around it. So we've been scoring our hybrids on a 1 to 9 scale, but there's really 3 buckets that you need to think about. First off, you're never going to see something that's rated from 1 to 3. Those products never see a Pioneer bag. They don't make the cut. So we can go around and we can say all of our children are above average. But we do have some that are hybrids of a 4. And those are hybrids that when you put them out in a tar spot area, you need to have a plan to manage with fungicide. There might be agronomically something that you really like about that hybrid that you want to put it in your area, but just be aware that tar spot's going to be a risk. Our average hybrids score 5. And then our above average is going to be 6+ scores. And as we refine our screening and we start specifically selecting for tar spot resistance, you're going to see more things getting up into those 7 and 8s. Really, though, if we have a major tar spot outbreak, we still recommend fungicide application as a best management practice for all scores. Here's a picture of one of those impact plots I was talking about. And this really shows the difference in tar spot response. The hybrid that was planted around the plot was rated a 7. So you can see it's still really nice and green. 6s are similar, but looking a little more yellow. But when you look at the 5s, there you're seeing a lot of plant necrosis, and the 4s have really started to accelerate that premature death and are drying down. Back here, I'm speculating, but in these rows kind of more towards the top of the image, where you can really see ground between the rows, those are probably things that would have been a 2 or a 3, but like I said, just never saw the light of day as a commercial product. One thing to remember is that average scores are not the same across the seed industry. So even though another company might say that they have an average performance, we've got P1222AM here, which is rated a 5 against a competitor who rates this hybrid as average. This is from Western Illinois 2 years ago. And you can see the difference in yield, difference in plant health and standability there. Another drone picture just showing a Pioneer 6 versus something else that is average. And so you want to rate apples to apples. So you want to rate within a company's own rating systems. A Pioneer 5 and 6 are really still pretty strong. And a Pioneer 4, like I said, just needs to be in your awareness and be managed. Spraying thresholds. We've been working with this for a couple of years now. We've been doing some work looking at return on investment trials for fungicide application. Also working on our fungicide timing tool, which helps predict your fungicide timing based on your planting date and your local weather, so that you can kind of spray while still in that latency period. Maybe it's not showing up to you visually completely yet, but we know based on our disease models that it's coming in. So that's something that we're working on. When you're just going visually, when you start seeing 7 to 10% leaf coverage in the lower canopy, so below the ear leaf, that's when you really need to start thinking that, hey, I'm going to need to spray. And what we found, although we can really fine tune our timing with something like our fungicide timing tool, in most cases, R2 seems to be the time to spray fungicide if you are going for corn grain. I know Greg's going to talk a little bit differently about silage, but if you're looking at corn grain, seems like applying at that VT to R2 gets you the lowest final disease index. This is a fungicide timing study done by Purdue University. And in this, they just went ahead and they sprayed fungicide kind of at every stage just to evaluate how effective the spray was. They discovered the disease on July 29th. So that was between V10 and tasseling. The crop became mature on September 29th. And so when they looked at the percent of the ear leaf affected when they applied the fungicide at R2, we were only about 1% infected of the ear leaf, but that gave us the lowest final disease index number. So that did the best job of suppressing the disease for the entire season. There's also some differences in fungicide efficacy in tar spot. So here, the lower the bar, the less tar spot was on the leaf, and so the better it worked. Everything in this green box here statistically is very similar to each other. So you've got a lot of options when it comes to fungicide. The two really good things about this disease are that hybrids and fungicide, or hybrid selection and fungicide management, can really make a difference in your farm on how much this disease will spread. So just to cap off the key learnings, once tar spot is present, it's present. You guys have it now. It's not going to go away. It's present in the crop residue of enough fields that it's going to be present probably on your farm. But you can plan for it. You can manage it with tolerant hybrids and fungicide. Don't panic over when it shows up. Stick to that R2 timing for grain or tassel timing for silage. We had tar spot show up in early June this year over in Iowa. And yeah, there was a lot of panic about if it's here in June, how bad is it going to get? How many times are we going to have to spray? And it looks like that generally R2 timing is still what we needed to do. But also just remember, it will compound any other stress in the field. So consider that in fungicide decisions. If you had wet feet early, or if you have a droughtier situations or something else stressing the crop, it's going to move faster through your crop than it would through a healthy crop. So consider that in your fungicide decisions. So thank you so much for having me this morning, and I will turn things back over to the group.
All right, thanks, Mary. John, Greg, do you want to take it from here?
Sure.
Talk a little bit about the local experience.
Yeah, so I hope you can see the slide that I popped up here, and I just want to use this as a bit of a background as we can we talk a little bit that a local experience that you're talking about, and what we're learning here in Southwestern Ontario and across really all of Ontario now. As we've mentioned many times, we're starting to see the disease and getting positive confirmations into Quebec even, as we're starting to see the continued spread of tar spot and then the continued kind of overwintering of it here in Southwestern Ontario. So I was very glad to hear all of Mary's presentation, because it's so nice to see that like the things we're learning really align with the things that the US, who arguably has had more experience and a few years head start on us, is learning too. And it's nice to see that all of those things for their environment are meshing quite well with our environment too. So I guess I'll start by just kind of highlighting the maps that are up here, right? Mary covered some of these. I've zoomed in on them just so we can see and take a look at that spread. But there is really kind of an amazing progression of tar spots forward, right? And huge amount of it is linked to the weather and the environment that we're seeing, right? You see the kind of larger outbreak in 2021 that we first experienced, right? And that's not to say that it hit hard across all of those counties by any means. I think in 2021, John started to feel that a little bit more kind of in the geography south of London, and I'll let him talk to that. All of the counties that I kind of cover, Perth, Huron, Bruce, and then up into Grey and almost all the way up to Barrie, basically saw tar spot that year, but it was very late. Didn't drive much impact, but it's there, right? And those pathogens are now there and overwintering. And we can kind of see, environment in 2022 not conducive again to really drive a huge impact from tar spot. And I think, John, you can comment on 2022 as well, with less impact even south of London, although the disease did show up again. You're going to get these kind of ebb and flow of the disease based on that disease triangle that, we always have to talk about. Thank you for sharing that, Mary. That's good. When you have that host pathogen, or that host, like Mary suggested, right, that's tolerant, you can narrow up that triangle, right? But then when the environment's not there, you narrow up that triangle as well. So I mean, we're seeing that variability year in, year out from this disease, but it's still present. And that's what we all need to kind of hear. It's here. If the environment is there, the pathogen is here. It's not changing. And so there is going to be a threat and a risk that we need to control. The one thing we can control with management, right, with choosing the right genetic tolerance and planning for a fungicide. So I'll stop there, and I'll kind of turn it over to John, so you can give us kind of a historical perspective on what kind of happened when it first came into the south, John, and then I'll kind of go over what we're seeing kind of in the north this year. And I also wanted to touch on a key piece with what we're learning about silage. I know, John, you don't have a ton of livestock south of London, but I certainly do as we get north of London, and we'll talk about that too. So.
Yeah. Can you hear me fine?
Yeah.
Good. Yeah, so I think what I wanted to share with the audience this morning was, the speed at which this disease moved across our territory. And if you look at that 2020 map and look at the counties that had a positive identification of the disease, that probably, misrepresents how common it was to walk into a field and see it. The epicenter, or the initial infection, was in that Rodney area where where Albert Tenuta is doing a lot of screening and a lot of testing since that point in time. But that in 2020, I had a hard time finding any infection across fields. And what was really incredible was 2021, when the environment was clearly quite conducive. It was not difficult to find it, and it spread across the area, and I think it surprised a lot of us. So bottom line is, environment does clearly play an important role. 2022, again, later infection, a lighter spread of the disease, and I don't think people really felt like it impacted their crop nearly as much in 2022. Now, fast forward to 2024, and there isn't a cornfield in the territory that I cover or the deep Southwest that you're not going to find tar spot in. It's essentially in every field. The question is, how early did it arrive? Was it protected with a fungicide? And I will say this: corn harvest has started across the area, just nicely getting started, but a couple of anecdotal way offs where we've had an opportunity to see fungicide versus no fungicide. And the worst case I've heard is 70 bushel spread. Is it always going to be something dramatic like that? I don't think so. But there's a lot of factors at play. Mary did a really nice job of highlighting the fact that tar spot can accentuate some of the other stresses that we're seeing. And I know across our area, we experienced, kind of that late season drought. The rain shut off, and our crop probably was impacted by some of those fields that had heavier tar spot pressure. So we're still learning. I'm still learning, and we're getting a handle on it. But it's definitely a disease that growers need to respect in terms of what it has potential to do to your corn crop. I think I'm gonna leave it at that, Greg, and let you share some of that silage information. And I do have some animals in my area, just so you know.
Thanks. Yeah, and I'll give you a bit of historical kind of perspective on our area too, where you kind of really started to struggle, John, in 2021 with that environment. Our environment was kind of conducive too, but we didn't have a huge amount of pathogen pressure yet, and it came in late for us. 2022, again, we saw it, but not much. And then 2023, which I regrettably don't have a map on the IPM pipe system for, it did come in again late for the area north of London. And I think it probably had a bigger impact than most people realize. We saw the crop dry down pretty quickly, a little abnormally, saw a little bit of light test weight, and it didn't see much of a yield impact. But definitely saw some of that amplification effect where we had other stressors and other diseases kind of going on in our environment last year in 2023 that I think tar spot certainly didn't help with. It complicated. It may not have been the main driving factor, but it amplified effects across multiple factors. And now again in 2024, we're seeing some of that same thing. And for the first time, kind of north of London, we started to see that infection. We started to see some stroma show up at the very end of June in a few plots, and got positive confirmation of that in early July, and have seen the disease kind of take hold from there. Right now, I think luckily the message got out. We've been talking about tar spot for a couple of winters, right? We've never really felt that impact, other than maybe the southern area who's seen those big yield swings and felt some of that real impact in their pocketbooks from this disease. But now it's starting to show up elsewhere. And it's certainly not everywhere, but there are pockets, and you don't have to look far in the geography I cover to find those pockets where tar spot has had a real big impact. And other areas where it may not be stealing a lot of yield, but it's amplifying the impact of the drought stress that we experienced late in the summer. It's kind of shut plants down fairly quickly, and the grain may have finished off nicely, but they've cannibalized the stalks in order to finish that grain nicely, and stalks are weak. And because that plant hasn't been healthy, now some other diseases are coming in. Some of the crown rots and some of those sort of things that do further weaken stalks are going to provide kind of a higher risk level than a lot of us really want to see as we kind of play this farming game and try to reduce our risk level as we go forward, right? So I think as you've learned, right, fungicide is a huge management tool. We've learned here, the genetic side of things is a really important management tool going forward. And then watching and doing the basic agronomy every year is going to be really important going forward, right? Understanding and scouting, knowing what the environmental pressures are for the disease to really have a big impact and take hold early. And watching and being aware of how wide the disease infection window is for tar spot is important, right? Because it's not just something that can, be a real problem if it takes hold in early July or even June, right? But it can rapidly ramp up under the right environment in August too, right? So we have to be careful of how wide the infection window is and stay on top of it and be prepared by budgeting, the right fungicide application and partnering that with good genetic selection as we go forward. So one thing I did want to talk about though, and I'll quickly just jump to it now, is try to jump to it if my slide will let me. Can everyone see the next slide there now? So the one thing I just wanted to quickly touch on was, I think a lot of the time we assume that tar spot is going to be a big impact on grain, right? Naturally, we talk yield, we think grain in our minds, we think of cash crops, we think of the yield impact that's going to have, right? And certainly this disease is not just isolated to grain and cash cropping. It's going to have an impact on silage and on feed as well. Now, thankfully, what we do know is that there are no toxins associated specifically with tar spot. So for the hog growers out there who are feeding high moisture or feeding grain, it's nice to know that the DON isn't associated with that. But I'll be careful in saying, though, there's that amplification effect too, and we're learning a lot about how tar spot can kind of come together with other diseases, ear molds, and those other stressors when the plant is weakened and not as healthy to fight things off, right? So it's not clear cut by any means. And as we think about silage and kind of that side of the industry too, we certainly get that plant health effect, those stressors that can allow root rots, things like that to come in, crown rots, whether it's fusarium, stalk rot or jib stalk rot. Some of those diseases that can produce toxins can slip in there too. They may not impact a cash cropper who's just taking the grain, but they might impact someone who's taking silage and fodder as well, right? Because the toxin could be coming through that. So there are some things to think through and watch out, right? But beyond kind of the yield standpoint, there is a significant quality aspect as well, right? And I stole some of what's on this slide from our dairy specialist in Michigan, Dan Bollinger, who I like his approach to silage, right? He's got this optimum harvest timing for corn silage kind of rule of thumb, which I have learned to really like over the years. And it's kind of apart from tar spot specifically, but really comments on plant health and where diseases really fit in there, right? And what we're trying to do with silage is we're trying to maximize the absolute amount of starch we can get in that grain for our feed, and we're still trying to get the right whole plant moisture so we can pack it properly in whatever bunk system that we're in, right? And typically we try to get as far along the path of 3/4 milk line as possible. That means your grain is going to be considerably drier, and we're trying to maintain a healthy plant so that you can get the whole plant moisture part right, with the moisture coming from the fodder instead. Now, what we're seeing with diseases like tar spot as they come in, because they dry that fodder so quickly, it's going to impact how those in our area who are heavy into livestock and use silage for pretty much all of their corn is into the silage system. You're going to have to watch how you harvest and when you harvest. And if tar spot is coming into a system, even if you've applied fungicide and it's taking hold, we're going to have to move that harvest date earlier and look to target that earlier milk line so that we're retaining the whole plant moisture from the grain itself rather than from the fodder. And the downside to that is that means typically less starch in that silage, right? It means, as the plant is naturally trying to cannibalize all the good stuff out of the stalks to put it into the grain, That means that it's not going to really affect your standability for silage. You'll still get it off in good time, but it is going to have stolen something from the nutritional value there, and it's going to leave you with a lot of reduced fiber digestibility, right? It's leaving all the junk that you don't want in the stock and not the healthy stuff that you want to ferment to get into your ration. So there are things to think through there with this disease in terms of how it can impact you, depending on what your farm operation is like, beyond just stealing grain yield potentially, right? And so I think that's kind of where I wanted to end on the silage side of things. But Chris, we're coming near the end of time, and I want to open up things to questions too. Certainly, there seems to be an endless amount of things we can talk about, but I'll turn it back over to you.
For sure. So thanks, guys. Thanks each and every one of you for presenting today. I got a couple questions in the chat here that I wanted to get to, and if you have some that are on your mind, just feel free to type them in here. But we'll get to the question period now. And in order to see those, I'll just so we had one it comes to Peter, just around the fisheye lesion. It comes from Jean-Marc. He's out in Quebec area, but it was kind of around if that's a result of a hypersensitive reaction to some genotypes. And is that what we're seeing, or is it that you mentioned the secondary infection? Can you unpack that a little bit more?
Yeah, so yeah, there have been that thought, or I have heard, whether this could be hypersensitive reaction. At least like if I talk about those that, for example, I show the pictures, I would say most likely not. It's just because usually what we see in other diseases, the hypersensitive reaction, it manifests a little bit differently. I mean, from the point of infection, you get more kind of like a yellow halo around, and not like in this case, you can see kind of like a necrosis really. So yeah, we don't think that it is a hypersensitive reaction.
I have a kind of a question leading into that too, around just, we hear a lot of single time looking at it. I've been out with farmers before and with this disease, and you take a look and you say, at the time you're in the field, you say, man, that looks really tough for tar spot, or man, this hybrid's doing really well. Can you help us understand, Peter, and maybe others with experience, just how we arrive at a score, and make sure that everyone knows that it's not just one time we're looking at a hybrid, and what goes into that. Peter, if you want to take that.
Yes. So actually, in research, whenever we have opportunity, we take two types of scores actually related to tar spot as of now. We do a one-time point when we consider that, that's the prime time to score, to give that final rating, those 1 to 9 ratings that we publish. But we do also do time series scores where we actually throughout the season, we evaluate the progress of this pathogen. So we get, both types of scorings. And we consider those when we are proposing the scores, the final scores for the product.
Yeah. Is there, you kind of see that influence of crop rotation and with this disease, John and Greg? Is that something you're watching with tar spot as it moves, and give us an understanding of how that works?
So from a crop rotation standpoint, like I think a lot of the time we think of, can we bury the disease, right? And so I cover Huron County, where we still like the plow a lot, and I'll tell you, we can't really bury the disease. And I think crop rotation, can we move away? Maybe if you move entirely away from corn, but that's not going to happen, right? Right? It's there's enough corn in the province. The spores can clearly move long distances on weather patterns and storm. Once it's in your area, it's in your area. If your neighbor or the neighboring county has tar spot, you're going to have it. And it's no different than some of the other diseases that we have too, right? And as we learn more, right? And I found fascinating in Peter's presentation today, that idea that there are potential other hosts depending on what isolate of the disease you're looking at. Like, the disease is here. It's regardless of if it's coming from ground zero in your field, right? Maybe you could assess that, like a corn on corn situation with heavy tar spot last year is at a little bit more threat, but it's still going to take hold regardless, right? If it's in your area, it's in your area. It's going to move to the corn at some point in time, right?
We've got a bunch of questions. Yeah. Go ahead.
Sorry, Chris. I'm just going to say one thing. As a good agronomist, I will never suggest that crop rotation is not a valuable, valuable tool. But in terms of, in terms of Southwestern Ontario, certainly, and probably the rest of Ontario now, it's not a lot different than jib from the standpoint that the inoculum is here, and it's going to present itself in the season where the environment's going to be conducive to that infection. So I don't. It will be something that we will continue to manage. Crop rotation could be helpful in that matter.
We've had a bunch of questions just come in on fungicide timing, and I do want to get into that more, and maybe that's something we should be focusing on more as an industry. And I know there's a lot of work being done, but do you have an understanding, like a lot of times it takes 2 fungicide passes, people are starting to believe, to really get control of tar spot. Timing, is there anything you want to touch on, John and Greg, with that, and maybe Mary as well, just with experience in the US?
Sure. So I could jump in and give you kind of my thoughts and observations from trials and things that we've done out there. I would say, Mary presented really nicely. I think that R2 timing is ideal, right? And a lot of the work that Albert Tenuta has done here in Ontario would line up with that, right? Suggesting that kind of VT to R3 window is best from an ROI standpoint for growers. Typically, what we've done in our area, and I think, John, you're fairly well aligned with it, is move to the recommendation of doing it more at R1 stage, and wanting to target fresh silks. And we have to understand that at that timing, there are a pile of other diseases, and specifically jib ear rot in Southwestern Ontario, or parts of Southwestern Ontario, that we are quite concerned about. And that's our ideal timing for trying to suppress those diseases. Thankfully, there's a couple products on the market, and I'm thinking there's a couple that have fungicide products on the market that are labeled for control of tar spot, that also offer some of that suppression of jib, right? So trying to go after both diseases at the same time, we're moving to that R1 recommendation, and we're seeing really good success with that. There are differences across those products, for sure, in terms of what we're observing, in terms of how long they can provide protection and how well they provide it. I'd say the ones that are labeled for control do the best job in terms of length of period of protection. They usually get you from R1 well past R3 before you start to see the disease kind of take off again. And I have yet to kind of see a real impact on yield of an application later than that R3 stage. I'm not saying that it won't protect some of the stalks and the weaknesses that we can see arise after that kind of that dent stage, but certainly we're not protecting any more grain at that point in time, or saving ourselves yield. So it comes down to more of an ROI discussion than what we can physically do with the plant at that point.
Yeah, I can jump in here too, Greg, because we've had some studies in Western Illinois for a couple of years now looking at 1 versus 2 fungicide passes. And what we're finding is that in years that are very wet, very conducive to disease, we do see a return on investment sometimes in those with those second passes. This is in an environment that is very high corn yield potential, and they're really going for maximum yields rather than tar spot suppression. So I don't know that you're going to get, if you're just looking for tar spot suppression or control, I don't know that you're going to need to have that second fungicide application most years. If you are trying to preserve just outstanding yield potential, one of those kind of swinging for the fences type of fields, you'll probably get some return on that in a wet year.
Yeah, and I'm just going to say that I think there's a number of operations this year that have experimented with a second application, and the results are yet to come in. And in good agronomy fashion, I'm going to say it depends. And you know, for us as an industry to be able to give you a straight up answer that 2 is better than 1 is better than none, it is going to be highly dependent on the season. It's going to interact with the product that you're growing, what that tolerance level is of that hybrid that you're growing. So those are all factors that play into it. But it will be very interesting, and I'm very interested to see the results that are going to show up this year from some of the second applications that were utilized in the field.
There's a question around harvest moistures. You know, just choosing to breed for plant health over the years, those kinds of things definitely have an impact on that over time. It's had an impact on our tar spot as well, I think, as we've gone forward. Maybe it's safe to say that, but is there, just with respect to not spraying a hybrid for tar spot and relying solely on tolerance, we talked about that probably not being the best strategy, but is there, you know, a negative yield impact on that that's, you know, substantial enough that you know, just from a harvest moisture standpoint, like I don't know if I'm wording that question correctly as the customer stated it, but yeah.
You know, looking at our germplasm over the last couple of years, one of the questions that I get asked is, you know, how did we end up with as much tar spot tolerance as we have in our lineup? And I think it's because we've been selecting for hybrids that gain yield because of strong late season plant health. You look at our kernel fill time and the depth of kernel fill, we get a lot of yield out of that. So if you're already selecting products that are healthier late in the season, you're probably selecting things that, but by happy accident, were also pretty resistant to tar spot when they started coming in. I would not, on our farm in Indiana, if we had heavy tar spot that was at a threshold to spray, I would not forego spraying in order to have drier corn. I think that the yield loss that you will have will outweigh any drying costs that you will have from your fungicide application.
John, Greg, any comments around that for Ontario?
I just say, like, you know, this year, as we've seen far more application of fungicide in my territory because specifically of tar spot, we have seen there's seemingly a separation of where moistures are at, right? We've had a fall that's been very, very conducive to dry down once we hit black layer. And there are some products that are coming off the field now at kind of 19 to 22% unsprayed. And there is a bit of a gap to where the products sprayed with fungicide are, right? Where they are a little wetter. But even then, for where we're at in October, they are not outside of the window of being concerned. And frankly, I gotta believe there's higher yield and better test weight and quality and better stock strength in those fields that were treated with fungicide, that they will safely be into our normal harvest window. If we're getting into that point where we're seeing grain way too wet, I'd also call into question whether or not we're pushing relative maturities a little too far. And there is that temptation for us agronomically too, as we continue to chase yield, to push relative maturities. And it's going to be a fine balance as we go forward. But I think one of the strengths of Pioneer, of course, is just how well our products are performing on tar spot, in that you don't have to jump up significantly in a relative maturity to try to get that protection. There's products throughout our entire lineup that will fill that option for you. So you may even be able to drop down to even a day or two earlier than you typically are getting to combat some of that moisture, and you'll still retain the yield and get the tar spot protection.
Very good. Peter, Mary, I want to thank you guys for joining us today. Really appreciate having your expertise to help us through this in Ontario and in Quebec. And John and Greg, thank you as well for joining and giving up your time this Friday to talk about tar spot with our customers in Ontario. We want to thank you guys for joining us, all that are on. Please, if you have any more questions, there's lots of people around you that are here to help. And I think of the Pioneer sales reps that are ready to have a conversation with you about this if this is something that is concerning your operation. With that, I just want to wish you guys a safe harvest and a productive one. And we thank you for your time and your business, and want to just wish you the best as you head into the fall here. Thank you. Have a great day.